Did you know that something invisible makes up 80% of our universe and we can see none of it? That something is called dark matter. Well, simply put, dark matter is a mysterious type of matter that does not emit or absorb any form of electromagnetic radiation, and yes, that includes light as well. It's kind of like a really thin sheet of super clean glass. First of all, dark matter is everywhere. Here, let me show you. Have a look at this picture. Everything you can see, the stars and galaxies, and everything that you can't, the coal gas, the atoms and molecules, make up just 4.6% of the universe's mass energy. Yep, you heard me right. Everything we have, can, or will ever see makes up just under 5% of the entire universe. And dark matter constitutes about 24% of our universe and the rest by dark energy. This is what 5% looks like. So, how did we discover this stuff if we can't see it? Well, it's kinda like wind. You can't see wind, but you can see the effect it has, like a paper fluttering or... Given by the virial theorem, astronomers can figure out the mass of a galaxy by observing the motions of its stars and gas. But the thing is, the observation suggested a gravity from a mass so large we would need 10 times the visible mass to account for it. What would explain this mystery is if there was some sort of invisible mass present, some kind of unseeable matter that was creating this gravity. Let me help you visualize this. So here I've got a freshly brewed cup of Milky Way from the Galactic Cafe. Let's weigh it, shall we? About 1.5 raised to the 10 power 12 solar masses. Pretty hefty. Let us take out all this visible matter, the stars, the planets, the comets, dust, coal gas, heck, even atoms. And let's weigh it again. 1.41 into 10 power 12. That's weird, isn't it? That mass seems to be from nowhere. And this mass discrepancy is made up for by dark matter. So, how do we detect this? Gravitational lensing. See this picture here? See those arcs and smears? That's caused due to the light being bent by gravity. By measuring how background galaxies are distorted by the cluster in front of it, astronomers can measure the mass of the cluster, and yet again, it turns out the calculated mass is 5 times larger than what mass all the stars, gas, and dust could provide. What is this mysterious form of matter made of? We don't know. But we speculate that dark matter may be composed of exotic subatomic particles that only interact with gravity and the weak force, and are known as weakly interacting massive particles, WIMPs for short. We have found no evidence of it so far, yet, and particle physicists are hard at work to discover it. And perhaps the most important question of all, why is dark matter so important? You see, after the Big Bang, the temperatures and pressures were just too high to form small structures like stars. But the gravity from the dark matter increased the compaction force, thereby allowing the formation of these structures. Dark matter seemed to have formed a really intricate and beautiful net-like structure across the universe, and sure enough, all the regular matter was attracted to the gravity of the dark matter, and thereby creating the structure of the very universe as we know it. So, when the universe is so full of matter that we can't see, do we just not matter?